Through our presentation, we will mention 4 parts. Our team, our design, our pattern, and our business application. So I will first explain our team. Our team, CTY, consists of 7 students. CTY is the project scientist. Sun Haiwo is the project manager. I am the project leader. Haodong is the project scientist. Project distribution engineer. Du Pengyue is the project coordinator. And Jing Hongpeng is responsible for marketing and communication. The position of project association is given to Qin Yufan. However, the huge amount of work required for the challenge makes the team impossible to finish the task without the help of mentors. Some of our teammates cannot make the trip due to the traveling fee. I want to thank all my teammates and mentors.
Thanks for the illustration introduction. Now I will introduce the goal of our team. In about 50 years or ahead, due to the rapidly increasing population, the food might be lacking. Consequently, the most important consideration is to produce a kind of aerial vehicles which are capable of detecting the moisture content of the crops, so that we can give a helping hand to farmers. Thus, they grow crops more efficiently. To reach our goal, we started to think about the key features of our aircraft and manage vision. After a series of discussion, we concluded those characteristics which needed to be the distinct elements of vision. First, the power supply. Our solution is using fuel and supplementary electricity to make our aircraft work. By sending electricity almost immediately to the engine, our aircraft have high speed during the early period of the launch time. A special made reduction gear could absorb the energy when our aircraft is slowing down, during which the gear acts like a brake. Thus, energy as well as the cost of fuel being saved and the harm done to the environment is reduced. Second, the outlook. We should design a completely innovative model to guarantee efficiency while doing these tasks. Added costs of using multiple UAVs should be avoided. Third, innovative approaches. A new approach which can detect the moisture content for a long distance is needed. We also need a device with a large memory to store more data. Besides, our aircraft should be easily handled. Considering transport our aircraft from one field to another is difficult, we agree on buying a van to carry the aircraft and the equipment for ground station. What's more, we decided to use multiple UAVs to cover grounds. Also, the cost may increase. The higher efficiency could bring us more profits. And finally, here are the characteristics of our design. Our aircraft could be capable of finishing the detection of the moisture content within 4 hours. The total cost of the aircraft is less than $16,000. It is able to operate it by a minimum of 4 operators, and it has a low rate of fuel consumption. Thanks for the introduction.
Please allow me to illustrate our models. One of our preliminary design model is model flowing. The biggest merit of the aircraft is its high speed and flexibility. However, its inabilities to endure a lasting time of traveling and complete missions in large-scale fields are the major drawbacks. The other preliminary design model is the vision. The vision has an incredible potential to carry on immense weight. Long body and long wings enable vision to have a high level of lifting force, which directly led to the outstanding performance of the aircraft. Such feature would also lead to the indispensable endurance of division. In the detailed design, our team chooses the division. In the first draft, we add a vertical wing. The vertical wing, on one hand, can improve the controllability of the aircraft. On the other hand, such measure could also help balance the whole plane by providing extra lifting force. Since the purpose of the whole project is to detect the moisture content of the target field, the technology applied in moisture detection is the key factor influencing the outcome. Our team chose to use the wireless blade surface moisture content sensor produced by Xinxin Wulian. It is a company from China and provides high-quality products for the clients. The sensor detects the moisture content by adopting a theory of electric resistance. The sensor simulates the process of blade acquiring moisture and therefore calculates the moisture content within the prop. Given the components and the whole flight vehicle weight and balance figure, the structure of the division is reasonable. The center of gravity of the division is relatively at the back of the aircraft. The project scientist Xu Jinyu suggested adding a counterweight object in the front of the division. So the center of gravity of the aircraft can move forward, thus helping the whole plane flying better. Here is the 3D view of final UAV of our team.
Alright, thanks for Sun's introduction, and we'll come to part 3. Let me give you a brief talk about our plans, flight patterns, and our crew. At first, we discussed which plants to grow in our experimental fields. As we all know, wheat is the most planted crop all over the world, and potato is the potential main crop in 20 years ahead. They both have advantages over other plants, so we choose them as our final plants. Then we made a very complex route for our flight pattern in order to make sure that the whole farmland can be covered. However, after a series of discussion, we noticed that the farmer flight pattern costs too much time in the fields, and the cost of the operation of our flight pattern will increase a lot. As a result, we changed our mind and work it out to get to know the speed of our plane and the fuel that it will cost per kilometer by some of the formula, so as the outcome. So, alright, the first picture is our former flight pattern, and the second is the improved one. After a series of calculation, we worked out our final flight pattern. This is the third one. Besides, the constitute of our detection team is 2 operational pilots and 1 support staff. They will take all the job of the support, control, command, and communication. The vision have an enormous fuel tank and a huge storage battery, which can make it have a great amount of power on the plane.
After things like the elementary design and the action plan are ready, we will need a business plan to gain more profits. The first part is a small 5-year plan. About money, we chose the most important part and showed it on the PowerPoint. As you can see, we will finish 200 tasks during the first year. The time to finish one field is about 2 hours, so we will have a lot of spare time. We will still devote ourselves to make make our UAVs more beautiful and better perform during the spare time. In order to achieve these goals, we will ask the consumers how they feel about our UAVs and which parts and skill can be improved in their opinion after the service. And then after 5 years' efforts, we will decrease the time to 1.5 hours. And according to the time decrease, the number of tasks we will finish can be increased to 250. And then some people may have a question, why they will buy our service or why our UAVs are better than others. First of all, we have better after-sales service than others. We will provide people who control the UAVs and a person who drive a car. And then we can change the equipment during the tasks and the speed or accuracy. Speed and accuracy according to the consumer's needs. So that can let most of the farmers feel satisfied with our service. In brief, we are sure during the period we cannot do the job, we will do some other commercial application. One of that is that the vision could be capable of helping the farmers grazing the cattle on the slope and other kinds of areas. Second, our UAVs can change the payload in order to qualify the targets of spraying the pesticide for farmers. Finally, our plan can also conduct data of areas which are prohibited for humans to enter. In brief, we are sure our UAVs will have a bright future because it is widely used and can be used for a longer time than others. Besides, our good after-sales service can attract more consumers for us. And in the end, I want to emphasize on the objective function. It's about 0.15. 0.51. And then I want to say something about this number. So, although the number is not very high, but we think, in our opinion, it is the best number because we achieve balancing the cost and the performance of our UAVs. So it is the best number for our UAVs. That's all.